Historic and Ecogeographic Processes in Speciation. I'm David Pauly from Indiana University. This talk is about how glacial cycles alter the geography of speciation, and in it I'm going to argue that the mode of speciation has changed progressively from 5 million years ago to the present as Earth's climate has moved deeper and deeper into glacial interglacial cycles. I'm going to look specifically in this talk at speciation in the Sorex araneus arcticus group, a group of shrews that share a unique chromosome system, XXXYY, and which are distributed in North America, Sorex arcticus, and Eurasia, with three species that have exceptionally large ranges, Sorex tundrensis, Delphinodon, and araneus, and several peripheral isolate groups. It's important to note that these species are essentially ecological clones of one another. All of them are dietary clones, mostly consisting of earthworms and spiders, and all of them except Sorex tundrensis are climatic clones of one another, occupying exactly the same climate space, just in geographic locations. Sorex tundrensis uniquely is specialized in exceptionally cold climates. It's also important to note that Sorex araneus, one of the large range species, is itself subdivided into 75 or more karyotypic races, a group of geographically contiguous or recently separated populations which share the same set of metacentrics and acrocentrics by descent. The dots on the map are showing the location of different chromosomal groups. Each of these groups differs from one another by Robertsonian variance, in which the arms of chromosomes are mixed and matched in different ways, either as metacentrics with two arms, acrocentrics with one arm, and from one race to another, what are called whole arm reciprocal translocations, where the arms are mixed and matched in different ways. There are hybrid zones between races, including the Moscow-Seliger shown here near Moscow. The Novosibirsk hybrid zone is shown here near Novosibirsk, Siberia. And when two metacentric races come together, during meiosis, their chromosomes, in order to align, have to form large chains or rings, which creates hybrid infertility and tension zones. Sorex araneus is a classic example of postglacial expansion. This paper by Hewitt in 1999 identified, using molecular phylogeography, parallel patterns in European species, which seem to have origins in the southern peninsulas of Europe and phylogeographic groups that represented northward expansion out of these refugia in postglacial times. Gene flow is rampant across the hybrid zones despite the metacentric incompatibilities. This study by Horn et al. Across several hybrid zones in the Sorex araneus range showed that there was substantial gene flow and perhaps even unimpeded gene flow across them. This raises the question whether Sorex araneus is speciating or despeciating. I am going to take a uniquely paleontological look at this system and ask several questions. How does the timing of speciation events in this clade relate to global climatic change? Where precisely were the glacial refugia, and how does the timing of glacial cycles relate to the nature and timing of divergence within and between the species and the karyotypic races in this group? Glacial interglacial cycles are now well understood. Here on the left, you see an oxygen isotope record of the last 500,000 years of global climatic history. The system is divided into what is known as oxygen isotope stages, which are numbered 1, 2, 3, 4, 5, etc., with the odd numbers being warm stages and the even numbers being cold stages. On the right, you see the longer-term history of Earth's climate. Prior to about 2.5 million years ago, climate was warmer than it is today, shown here with the blue hatched line. And as we moved into what is now known as the Quaternary, we got the onset of glacial ice in the northern hemisphere, and a generally declining global temperature with increasing fluctuations between warmer and colder periods. Those cycles at first were 41,000 years in duration, and for about the last 750,000 years, they have been 100,000 years in duration, as we just saw. As global climate has turned down and glacial interglacial cycles become more intense, We've had the origin of several Arctic biomes, including tundra, boreal forest, alpine areas, and the now extinct mammoth steppe. The fossil record of Sorex araneus is especially good. Here in the center, you see the locations of dated Sorex araneus fossil sites, largely from the compilations by Barbara Resbeck-Kowalskova. You see a typical fossil here. Many of these sites are now extremely well dated and can at least be slotted into one of the oxygen isotope stages. So the first thing we want to do is look at the timing of speciation events in the Sorex araneus group relative to this global climatic history. The dark red lines show the fossil record of Sorex araneus, showing when the oldest occurrences are, which gives us a minimum time of divergence, and then a molecular clock window is shown here, which is when climate was starting to turn down. We can also ask where glacial refugia were. And what you see on the left is a map of the last glacial maximum time. The red dots are where we have fossil localities at the time of the last glacial maximum. So we have a positive record of species there. And then the green patches are a species distribution model that show where climate in the last glacial maximum time was similar to climate in the current distribution of Sorex araneus. There is a big patch of potential refugia over here that is not just in these peninsula, but also north of the Alps. There are smaller patches through Siberia, and then there are several large patches on the Pacific coast. One important feature of glacial interglacial cycles is they are asymmetric. If we take this last 500,000 years of climate history, bin it, and make a histogram of it, we get a distribution like this, where this is modern temperature, this is the last glacial maximum temperature, and most of the time is skewed more towards the colder regime. What that means is that geographic ranges have spent more time allopatrically divided into refugia than they have into an expanded post-glacial contact. In other words, we can have lots of differentiation in this fragmented time and in only a small amount of time of losing that differentiation by gene flow. Those expansions and patterns map very well onto the phylogeographic model of the karyotypic races, which is shown here, worked out by White et al. Putting all of this together into a geographic scenario of speciation, in the West, we have today karyotypic races which have very small geographic ranges and quite a lot of gene flow between them and very little differentiation. In Siberia, we have large geographic ranges and quite a lot of differentiation. Elsewhere, we have completely isolated patches that have resulted in speciation events. And so we can put this together and give a stepwise model for speciation. At the onset of the Quaternary, we got ecological speciation. Early in the Quaternary, we would have gotten splits between the most climatically isolated areas like the Tian Shan Mountains. And then in the latter part of the Quaternary, as we start to cycle with quite extreme glacial and interglacial cycles, we get what we call the two-step forward, one-step back model, in which karyotypic races are isolated in small refugia for a long amount of time. Then they come back into briefer periods of allopatry and despeciate for a while. There is progressively more differentiation with each glacial cycle. Is this model generalizable? You don't have to look hard to find mid-latitude mammal species in North America and Eurasia that have a very similar geographic pattern among species with large ranges. Is this model universal? The answer is probably no. It applies to strongly cycling environments in the Quaternary and especially the late Quaternary. It is probably also scale dependent, both geographically and body size, because differentiation depends on the balance of dispersal, gene flow, geographic range, and the durations of refugial allopatry and panmixia. Thank you very much for listening, and thanks to my collaborators.